Approximating distributions, the normal approximation to the Poisson distribution. Starting with a Poisson distribution, if you come across a problem where there are too many probabilities to calculate and probability tables for the Poisson are not available, then using a normal approximation is a possibility if lambda is greater than 10, with a continuity correction applied. In this example, lambda is equal to 19. That value is not in the probability tables in the formula book. Using the Poisson formula is impractical. There are too many calculations to do. Because the value of lambda is more than 10, we can use a normal approximation. For the normal distribution, we need a mean and a variance. And we know from the Poisson distribution, the mean and the variance are both equal to lambda. They're both the same. The mean value here is 19, and the variance is the same. For the continuity correction, we need values more than or equal to 25 here. We don't want the 24, we do want the 25. The boundary in between what we want and what we don't want is 24.5. So we work out the probability that x is greater than 24.5. This is our continuity correction. Standardizing the 24.5, so that's the x, 24.5, minus the mean, which is 19, dividing by the standard deviation. Remember, this is a variance, so divide by root 19 is equal to 1.26. So now we're working out the probability that z is greater than 1.26. We're looking for this small area here, so we do 1 minus the probability from the formula book to get 0.10383. This is the Poisson distribution that we started off with. You can see the individual discrete probabilities. It had a mean of 19. And if I superimpose the normal distribution that we've used for the approximation, you can see that the normal distribution is a good fit because the conditions for the approximation that lambda is more than 10 was met.